A conical pendulum is formed by attaching a 500-gram ball to a 1-meter long string, then allowing the mass to move in a horizontal circle of radius 20 centimeters. Figure shows that the string traces out the surface of a cone, hence the name. What is the tension in the string? What is the ball's speed? What is the period of the ball's orbit? Okay, now let us do the problem. Here, uh, the mass of the ball is given to us. Okay, mass is 500 grams, and then length of the string is given to us, and then radius is given to us. Okay, here is the length, and then this is making an angle theta with the vertical. The ball is making an angle theta with the vertical. Therefore, from the geometry of the figure, I have to find out theta. So what I do is I will write sine theta is equal to opposite side by hypotenuse. So opposite side is given to us because this is the r and this is the length L. L is equal to 1 meter. So sine theta is equal to r by L, and then r is, I will write here, r is equal to 20 centimeters. That is equal to 20 by 100. That is equal to 0.2 meters. Okay, length is equal to 1 meter. Therefore, this will become 0.2. Okay. Therefore, theta is equal to sine inverse 0.2. That gives an angle of 11.53 or 11.54 because this is 5369. Therefore, I can take 11.54. Okay. Rounding it. The first bit is we have to find out the tension in the string. For that, I have to resolve the forces into components. This is the F tension. Okay, the object is, the ball is rotating in a conical circular motion, and the string is making an angle theta. Therefore, the tension is making an angle theta with the vertical. Okay, now I have to resolve the tension into components. One is the vertical component, another one is the horizontal component. This is horizontal component tension Ft, and this is Ftx, I will write. And then this is the vertical component Fty. The vertical component of the tension force balances the weight Fg. Okay, and then the horizontal component of the tension provides the required centripetal force Fc. Okay, because this is directed towards the center, this provides the centripetal force. Okay, therefore I will write sigma Fx is equal to Ftx is equal to Fc. Okay. Another one is Fty sigma Fy. Sigma Fy is equal to Ft minus Fg is equal to 0 because there is no motion along the y direction. Therefore, Fty is equal to Fg. We know Fg is equal to mg. Okay. And then Fty. What is Fty? This is adjacent side to the angle. No? So this is Ft cos theta. So Ft cos theta is equal to mg. Okay, so therefore I will find out Ft from here. So Ft is equal to, mass is given as 500 grams. So m is equal to 500 means I will find out 500 grams. Therefore divided by 1000 gives 0.5 kilograms. Okay, so 0.5, and then G is equal to 9.8 meters per second square or kilogram per Newton per kilogram. Okay, so this is equal to 9.8 divided by cos theta. So cos 11.54. That gives a value of 5 newtons. Okay, and then next I will come to the x direction. This is the A bit. Okay, now I will come to the B bit. What is the B bit? B bit is I have to find out the ball's speed. So that I will find out from the x component forces. Ftx is, what is Ftx? Ftx is the opposite side to the angle. Therefore, Ft sine theta. Ft sine theta is equal to Fc, you know, Fc is equal to, I will write here, Fc is equal to MAC because Fc is the centripetal force. So centripetal force is equal to MAC. And then here, AC is equal to V square over R. Okay, so I will substitute this one. This is equal to mv square over R. Okay, and what all I know sine theta. Here sine theta is equal to 0.2, and then tension is 5 newtons, and then mass is known to me, and then R is also given to us. Mass and radius are given to us. Therefore, I can easily find out V square. Therefore, V square is equal to Fr times Ft sine theta divided by m. Okay, Rv is equal to square root of, now I will input the values. R is 0.2, am I right? And then Ft is 5 newtons. And then sine theta is equal to 0.2 divided by mass is equal to 0.5 kilograms. Okay, this gives a value of 0.6324 meters per second. But the textbook is asking us to find out in the rotations per minute. Okay, so to find the rotations per minute, what we have to do is we have to convert it. So we know V is equal to R omega. Okay, therefore omega is equal to V by R. Okay, so here V is equal to 0.6324 meters per second divided by R is 0.2. This gives 3.108 radians per second. Okay. Now, to convert the rotations per minute, what I have to do is I will write 2 pi radians is equal to 1 rotation. Okay, because this is the circle, no? One complete circle means 360 degrees. Okay, that is one rotation. 360 degrees means 2 pi. 2 pi radians. And then here it is in seconds, radians per second. So I will write for 1 second, it is making 3.1 radians. Okay. Now, 3.108 radians, how many rotations? Okay. So for that, what I will do, 3.108 radians divided by 2 pi gives the number of rotations per second. Okay, because these are these many radians per second. Therefore, this will become radians, rotations per second. Now I have to convert them into rotations per minute. So for that, what I do is once in 1 second, it is making 3.108 over 2 pi rotations. Okay, so in 1 minute means 60 seconds. In 60 seconds, how many? So for that, what I do is this multiplied by 60 gives the answer. 3.108 divided by 2 pi into 60. That is equal to 30 rotations per minute. This is what the textbook is asking, because he is asking us to convert meters per second to rotations per minute. Okay. Now the third bit I will do here. The third bit is he's asking us to find out the period, time period t is equal to question mark. How we have to find out the t? We know v is equal to distance over time. Distance is here 2 pi r over t. R t is equal to 2 pi r over v. Okay, so therefore t is equal to 2 pi r is 0.2 divided by velocity is 0.6324 meters per second. This gives 1.98 seconds, or t is equal to 2 seconds. Okay, so these are the answers for the question here. 5 newtons is our first, this is the first bit, this is the second bit, and this is the third bit. Okay, for this it is the 30 rotations per minute. Just we have to convert the meters per second to rotations per minute using the formula V is equal to R omega. Okay, so in this question, first you have to identify the forces, and then after identifying the forces, you have to draw the free body diagram, and then you have to equate them. Okay. And then the rest of the things are just plugging in the values. That's all. Okay. Hope this helps. Thank you. Bye-bye.